My name is Navya Vashni. In this project, I built a bank account management API using event sourcing and cqrs architecture. The tech stack I used is Node.js, Express, TypeScript, PostgreSQL, and Docker Compose. The problem this project solves is that traditional systems only store current state. But financial systems required full audit history, traceability, and time travel queries. So I implemented event sourcing, which store every change as an event, and cqrs separate write and read models. Real world use cases are: this architecture is used in banking, fintech, payment systems, and ledger systems where auditability and history tracking are critical. And my system has three main parts. There are command side, event store, and query side. Command side handles create account, deposit, withdraw, close account. These generate events. And event store, in this all events are stored in the events table. This is the single source of truth. And in query side, there are two tables: account summaries, transaction histories. These are updated by projections. I also implemented snapshotting every 50 events, and time travel queries, and a projection rebuild, and idempotency handling. This architecture gives full audit history, easy debugging, scalability, and time travel support. And here in my project I have domain, which contains bank account logic, and services which store with event store and a snapshot service, and routes, the API endpoints, and seats. In this we have a SQL schema, and a Docker compose.yml, and a Docker file, and a .env. And in bank account.ts, this contains all business rules like a deposit validation, withdraw validation, close account rules, and a duplicate transaction handling, and a balance updates. And in event store.ts, this file handles storing events, retrieving events, and maintaining correct event order. And a snapshot service.ts, this creates a snapshot after every 50 events, so we don't replay the full history every time. And routes, I implement all required endpoints like a post API accounts, and a post deposit, and post withdraw, and post close, get accounts by ID, and get events, and get balance set, and get transactions, post projections rebuild, get projection status. Here, command start my app and database with health checks. Yeah, it started, it is building. It successfully built. As you can see, server running on port 8080. And now we check, it's time to check the health of the database. Carl. As you get okay, everything is correct. And now we create an account. As you can see the message account creation accepted. This creates an account created event. And after this we implement deposit. Generates money deposited event. You can see the success message like deposit accepted. Now this command checks balance and generates a money withdraw event. You can see the success message like a withdraw accepted. And next one we implement get account. Here you can see this reads from projection table like account summaries. And now we implement get events audit logs. This shows full event history stored in event store. And this is the time travel query. This reconstructs balance at a past time using event replay. And after that, now transaction pagination. This returns paginated transaction history from projection. And now projection rebuild. This rebuilds read models from event store. And now projection status. Like this shows how up to date projections are. The hardest parts in this project were event replay logic and time travel calculation and handling duplicate transactions and a snapshot implementation. And bugs I faced are wrong timestamp comparison and a duplicate transaction bug and a projection rebuild issues. I fixed them by correct timestamp comparison, tracking transaction IDs, idempotent projection updates. And the limitations and the future improvements are current limitations are projections are synchronous and no authentication, no front end, no async messaging systems. And the future improvements are we use Kafka or RabbitMQ or and add authentication and add a front end UI or add event versioning and upcasting and add monitoring and logging. And this project helped me understand real world event driven systems, CQRS, and distributed architecture. Thank you.